So, in this week's homework videos, I'm going to go through a couple of the exercises from your homework set of exercises, some of the trickier ones, so that I can explain things through, and so that you hopefully then don't have any questions about how to manipulate powers. So the first exercise is on page 8 and is exercise 14, and we have 5 statements, and we need to say if these 5 statements are true for x in the set of real numbers excluding 0, and for y as just being a real number. And it's important to note that these conditions are important, especially this top one, as x here can't be 0 as we can't divide by 0. So let's go through and decide whether or not they're true. So number one I think is a misapplication of a common rule. If we write it out in full, we have x times x times x plus x times x, x cubed plus x squared. There's no way we can combine these powers to be x to the 5. Here, if we had a multiplication symbol rather than a plus, then of course we would have x times x times x times x times x, which would give us x to the 5, but we don't, we have a plus. And as you should be aware by now, we can't combine algebraic symbols with different powers. So this one is false, not correct. What about number 2? Here, again, it's possibly easiest to write out the expression in full. So we have x to the power of 4, which is x times by itself 4 times, and we have y to the power of 4, which is exactly the same for y. We want to see if this is equivalent of x times y to the power of 4, and because multiplication is commutative, we can multiply in any order we like. So in multiplication, the order doesn't matter. Let's just note that down. This means that we can change the order of these terms in this expression. So I can change this to be x times y times x times y times x times y times x times y. I've just moved each y in between two x's. And you can see then that I have 4 lots of x times y together, which is x times y to the power of 4. So this one here is true. What about number 3? Well, I think for number 3, it would be best to rearrange this left-hand side of the equation to see if we get the right-hand side. So let's do that in a little box over here to give us more space. So we have 3x minus, and then I'll multiply this bracket out with this x, and I'll keep note of the minus because they're easy to make mistakes with. So I have 2 times x is 2x, and minus x times x is minus x squared. And now I'll multiply out this minus. So I get 3x minus 2x plus x squared, which is x plus x squared, which is the other side. So this one is also true. Number 4, I'll make notes on the next slide. So again, this one is easiest to see by writing out the expression in full. So on the top we have x times itself 5 times. On the bottom we have x by itself 7 times. Which means that we could cancel. We can cancel this one with this one, 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 and this one with this one, leaving us x times x on the bottom. So on the top I'm left with 1, on the bottom I'm left with x squared, and of course, as we're familiar now with from class, this can be written as x to the power of negative 2. So let's see if that's the answer that the question gave us. This one was missing its minus, so this one is false. Question 5, again, it's good to write question 5 out in full, especially if you're not sure. So we had x to the power of 2 to the power of 3. So that's x times x to the power of 3, which is x times itself 3 times. So we have 1 lot, 2 lots, and 3 lots. So how many x's do we have in total? Because it's multiplication, I can just leave out all of the brackets. 1, 2, 3, 4, 5, 6. So that is x to the 6. And the shortcut rule that we had in class for this, if you remember, is that we multiplied these two powers together. If we had a power raised to another power, you multiply the powers together, so 2 times 3 gives you 6. Which means that this saying is equal to x to the power of 5 is also false. So you should have only put ticks next to these two answers here. So page 8, question 14 is answered. Let's move on to the next tricky one. For this one, I've selected exercise 24F on page 9, right at the bottom of the page. And we have this expression that we need to tidy up. So normally with these, you end up with something much smaller than the original result, and they can therefore be quite satisfying. So my first step is going to be getting rid of these squares. So I'm going to square everything that's inside the brackets. So my negative symbol here, my minus here, I could attach to the 6 or to the 5. It doesn't matter which one you attach it to, or you could just think of it as a negative 1 times that whole thing. There are a couple of ways that you can think about it, but it's important to remember that you should only deal with one minus when you have a negative fraction like this. Some people make the mistake of putting minus 6 and then also minus 5, but then of course if you've got a minus divided by a minus, it makes the whole expression positive. So make sure you only have one minus in here. In this case, we're squaring things anyway, so regardless of where we put this minus, it's going to become positive because we'll be multiplying it by itself. So if I consider minus 1 times minus 1 gives me positive 1 out the front, which then I don't need to write anymore, because positive 1 multiplied by anything is the thing itself. So then let's square the 6, so I get 36. Square the s to the power of 5. I can do this by doing the 5 multiplied by the 2, or you can write it out in full, as we did with the previous exercise. So then we have s to the power of 10, over 5 squared is 25, and t to the power of 3 squared would give us t to the power of 6. Again, you can do that by multiplying the 3 by the 2, or writing out in full if that makes you feel more comfortable. Divided by, again, I could think of this as a negative 1 squared, positive 1. 3 squared gives me 9. S squared squared gives me s to the power of 4. Over 15 squared, which is 225. T to the power of 4 squared is t to the power of 8. And it's worth noting here that when you square fractions, you square both the numerator and the denominator, both parts. A half squared, for example, is a quarter, 1 squared over 2 squared. Now what I'd like to sort out is this division sign, and hopefully you remember that if you divide a fraction by another fraction, then you can just turn this fraction, this second one, upside down, and it can change to multiplication. So that gives me 36 s to the power of 10 over 25 t to the power of 6 multiplied by 225 t to the power of 8 over 9 s to the power of 4. And now, because it's just multiplication, actually I can leave these brackets out. And in fact, what I could do in my next step is I could make it one whole fraction together. So that would give me 36 s to the power of 10 times 225 t to the power of 8. Of course, I could multiply the 36 and the 225 together on the top, but I'm not doing that yet for a specific reason. Over, in the denominator, 25 t to the 6 times 9 s to the 4. Then I can cancel. So 25 goes into itself once, that it goes into 225 9 times. Handily enough. And t to the 6 goes into itself once, and we can cancel 6 t's from this t to the 8 if you imagine this written out as t multiplied by itself 8 times, and this is t multiplied out by itself 6 times, then here we're left with t squared. Then I can cancel this 9, which I could do with the 36, but actually it's easier just to do it with this 9. And then s to the 4 cancels with all of these s's here, and I'm left with s to the 6. So overall, I'm left with 36 s to the power of 6 t squared. And hopefully, when you tried it on your own, you got the same solution. So, on to the final question that I'm going to take you through. And this one is question 35 on page 12. And this one is a classic Matura style exercise, where we have 4 different expressions on the left-hand side that we have to match with 1 out of 6 of the expressions on the right-hand side. Now my recommendation to you is start with the easiest one. So I'm going to start with number 3, because they all have the same base, it'll be really simple. So here I can use these multiplication rules that we met in class to simplify the numerator and then the denominator. So 10 to the power of negative 3 times 10 to the power of 2 minus 3 plus 2 is 10 to the power of negative 1 on the top, plus 0 is still 10 to the power of negative 1. On the bottom, negative 1 plus 4 gives me 10 to the power of 3. And then, using the division rules, I have then minus 1 minus 3 gives me a result of 10 to the power of negative 4, which, looking at the options from A to F, is the same as 1 over 10 to the power of 4, which is option F. So that one's done. The next easiest one, I would say, is probably number 2. So here we have negative 2 squared, which I'm going to simplify to be just 4, times 4 to the negative 3, times negative 5 cubed, over 5 squared, times by 2 to the power of 4, but I can use the fact that 2 squared is 4. So I know that this is 2 squared squared, so I can say that this is then 4 squared. So I can sort out my powers of 4. So up on the top I have 4 to the power of 1 minus 3 is 4 to the power of negative 2, times minus 5 cubed is minus 5 times minus 5 times minus 5. So this is actually minus 5 squared times minus 5. Bear with me with this one. Over 5 squared times 4 to the power of 2. Now negative 5 squared is going to be exactly the same as 5 squared, because if I square this, then the minus comes away, because minus times a minus is a plus. So these two can be cancelled. Then I have 4 to the power of minus 2, then take 2, because I'm dividing. So I have 4 to the power of minus 4 times negative 5. And of course that doesn't look like any of the options, although it looks quite similar to option E. So let's see if we can rearrange it into the form of option E. So that gives me negative 5 over 4 to the power of 4, which is then negative 5 over 2 squared to the power of 4, which is negative 5 over 2 to the power of 8, which is indeed option E. So 2 is also done. I'll finish the final 2 off in the next video, and that shouldn't take us very long.